So welcome back. We are going now to start doing the regression analysis, which is the main point of our whole thing. This is where we will test if this works or not. And I will go step by step, first doing the exercise with environmental sustainability awareness. You can do it like that, and then you do your own. But I will start just randomly with environmental sustainability awareness. So what you have to do is click on analyze, then regression, and then linear, like this. And you get this thing. All of you will have to put AI in the dependent variable because that's the same for everyone. And then I'm following the example of environmental sustainability awareness. I put my independent in here. If you want to do it like I do, just to see if you get the same numbers, do it like that. If not, just put your own variable. Before you click OK, go to statistics and click collinearity test, collinearity diagnostic, because we're going to test for that. And then click OK. I hope it doesn't take much time. I don't know what's going on with my computer. So let's wait. But what we are going to check are four things, if you remember from the lecture. We need to check the model fit. That is the first thing that we will check. We will also check the R square. We will discuss that. And then we will discuss the multicollinearity test. And then we will also discuss the uh, mm, the significance of the variable. So it took a long time, I don't know why, but let's do the analysis. The first thing that we need to check is the significance. This number here has to be less than 0.1. If it's not less than 0.1, we cannot do anything. We stop here. That's the conclusion for the first model. The model where we only have one variable, the conclusion is it doesn't work. The significance is not correct. You cannot do anything. You cannot conclude reject or support, nothing. It's just that this model doesn't work. Sometimes it happens. It's not the end of the world. There is nothing wrong with that. Let's now add more variables. So we are going to do that in here. We are going to add all of our control variables like this. And we are going to click OK, and let's see what happens. I don't know why it went so quick, but let's do the analysis. First test that we need to check the F value. Now this over here in the ANOVA, the significance is less than 0.1. That's very good. Now finally model fit, no problem. There is fit in the model. The significance of the F value is less than 0.001, so we can move forward. That's good. The next thing to check is the R square. We need to check this adjusted R square. Also connected to the lecture, you know what it means. Like the R square tells you how much of the variance of the dependent variable is explained by the variance of the variables in the model, and it's 19%. It's not that much, but for social sciences, it's fine. In engineering, this will be horrible. Imagine that you have a model where you can predict the outcome of a machine or something by 19%. That's horrible. Imagine that you fly an airplane where you can only understand 19% of what will happen. So in engineering, it doesn't work, but in social science, it's totally fine because actually, if you manage to understand 100% of what will happen, you are probably God. And so that never happens. So something, it can be as low as 2 or 3%. I mean, it's not the ideal, but it's okay. And if it's higher than 90%, like 0.9, it's a bit suspicious. So the R square, we have to discuss it, but we don't have like such a intense or rigor limitation. The next thing we need to check is the multicollinearity. In multicollinearity, we need to check this, the BIF statistic. We need to check that there is nothing higher than 4. If there is something higher than 4, you probably will have two because these two will be there will be collinearity between these two. You'll have to remove at least one. Sometimes this happens, for example, with experience and age. Like usually the older you are, the more experience you have. So sometimes in a sample where you have age and experience, you can have this, and we don't like that. So we need to remove that multicollinearity. But we don't have multicollinearity problem. So three things we have tested: the model fit, the R square, and this. everything we have passed. Let's move forward. The last thing to check is the significance of the variable that we care about, the sustainability awareness. And it has to be lower than 0.1. Sadly, or not sadly, but this is what it is not significant. It's zero 0.4. So that means there is no there is no significance on the relationship between environmental sustainability awareness and AI usage for this second model. The first model was only your variable sustainability awareness, and that's it. This second model is with some controls. So that's why we have that. The final conclusion is everything works, model fit, R square, no multicollinearity, everything works, but the interpretation is this model rejects the hypothesis. Wherever you have hypothesis, you reject it because it doesn't work. Like it's not significant. That's the conclusion for model 2. Now let's do model 3. Model 3 will be, just to keep it nice, I will remove controls first, and then I will add the other variables. I will use them as controls. Here, if you are doing something different, just add the other fours. Like if you have technology literacy as your variable, just do the other four, and then add the 6 control variables that we all have, and then click OK. Now it takes a lot of time. So while we wait, let's just maybe reflect a little bit on what will have happened if the significance is 0.1 or less. If that was 0.1 or less, we will have to check the sign of the coefficient. And if the sign is the same as your hypothesis, for example, if you assume a positive correlation, then you support the hypothesis. Otherwise, you also reject if the sign is not the sign that you expected to happen. So now let's analyze the final model, model 3, when you have all the variables. So first, model fit, yes, it works. It's less than 0.1. R square is fine, 0.18. No multicollinearity issues, it's perfect. And the significance of environmental sustainability awareness is 0.973, so also not significant. The conclusion for model 3 would be everything works, but it's not significant. So we reject the hypothesis for model 3. So the overall conclusion for environmental sustainability awareness, those groups, is full rejection. Why full rejection? Because the first model you cannot do anything, so we won't count model 1. But model 2 and model 3, these two models are rejection. So that's the final conclusion. You reject. That's the overall conclusion, is full rejection of the hypothesis. So that's the quantitative result of everything we have done. There is no relationship between environmental sustainability awareness and AI usage. Maybe in the problematization we claim it could happen, we needed to check, we check, and in this sample it doesn't work. So that has some consequences. You will learn how to do that in chapter 5, the discussion. Something interesting is for technology literacy, because everyone will have this model, the final model, we will all have the same numbers because it's everything, so it goes. Technology literacy is actually the only variable that, at least in model 3, is significant, and it's positive. So if your hypothesis is the higher technology literacy, the higher AI usage, positive relationship between technology literacy and AI usage, that means that you support the hypothesis in this model. You need to do the other models, only technology literacy, and second model technology literacy and the controls of gender, age, blah, blah. And let's see what happens. I think I did the test that quickly, and I think for technology literacy, everything works in all the models, I think, and the significance is fine in all the models, and it's always positive. So the final conclusion for technology literacy is full support of the hypothesis if you have a positive relationship in the hypothesis. So you fully support with all the models. That is the case of technology literacy. I did some tests, and I think, for example, professional aspirations, I think you have to do it. I think professional aspirations in the first model, everything works, and I think it's positive, the relationship, and it's significant. So let's assume that you support in the one. But in the other two, you reject, including this one. You can see that you reject for professional aspirations. So that means the final conclusion is partial rejection, because from three models, two are rejection and one is support. Another possibility could be the opposite. You support in two models and in one you reject. That means partial support. And the final thing that could happen is maybe uh, one doesn't work, one is support and one is reject. That means non-concluding findings or contradictory findings because you have one and one. That is the other combination. So in practice, there are five possibilities: full support, full reject, partial support, partial reject, and contradictory findings when you have one and one. So that's it. That's the regression analysis. In the next video, what we are going to do is come back to Excel. We learned how to, in video 2, how to move from Excel to SPSS. Now we need to learn how to move from SPSS to Excel. That's the last video you will do. And the outcome of that video is what you will upload in Canva.